Hi guys, good afternoon to all of you. So my name is Rajani and we'll be talking on NoOps for OpenSearch. So the future of self-healing search infrastructure. So this is the topic that we'll be talking about. But before getting started, I would like to introduce myself. So my name is Rajani Ekunde. Okay. So he told that I'm working with GlobalLogic, but that's not the scene. I have left the company, and I'll be joining a new company soon. And I'm a DevSecOps engineer by profession, by the way, and I'm a Docker captain as well. I got selected like 2-3 months before for Docker captain for my contribution in the Docker community, and some more things you can see: AWS community builder, WTF ambassador, and international speaker as well. So this is about myself. I would like to hand over the mic to my co-speaker for his introduction.
Good afternoon, everyone. So my name is Rajaram. So I work as a cloud lead in a fintech company. So where my role is to lift and shift the complete migration from on-premises to the cloud. So that was my role. So I majorly focus on banking domain. So along with that, I'm a AWS community builder, so which has been recently selected this year. And along with that, I do write a tech blogs on a Medium and then #node. And also I'm a public speaker, so I talk a lot about the cloud in current era, like what are the things which we are facing and what kind of issues we are facing, so on a real-time environment. So that's all about me. So let's go ahead and then look what we are going to talk about. So I'll just hand it over to Rajani to take it further.
Okay, so this is the agenda we are having. Okay, so as the topic, in the topic only we had this term NoOps. So first thing we'll talk about why exactly NoOps is needed, then what is the evolution of search infrastructure, then what exactly is OpenSearch, and when we are talking about NoOps, so how OpenSearch is having some powers and some pain points as well. Then what is the vision of NoOps for OpenSearch? Then the core enablers, we are having K-test, Terraform, AI, then we are having self-healing thing, like what exactly we are meaning when we are talking about self-healing with respect to OpenSearch. Then we are having automated scaling and what are the challenges with OpenSearch, and then we are having a demonstration as well. So this is the flow of the session today. Okay, so why NoOps? So anyone would like to give any definition about NoOps? What do you think NoOps is? Yes, exactly. So we can see that the term itself is telling us all the information. No ops, basically no operations. But exactly that is not the meaning. So no ops basically means that we are trying to eliminate all the manual intervention as much as possible. We are trying to eliminate the human intervention. Okay. So I would like to give a real life example here so that you can get a more good idea like what exactly we are trying to talk here. Like suppose if you are working with some company and you have worked all the way from Monday to Friday, and now on Friday night you are like, okay, so I'm gonna chill for next 2 days because I don't have any work. But suppose if you got an alarm or you got a message on your phone saying, okay, there is some issue happening with the prod, there is some node group, there is some pod which is causing the production to fail. So if you got such a notification, then definitely you have to go ahead and you have to debug what is the scene and you have to manually go and check. So this was the scenario before NoOps was in the picture, okay? So definitely suppose if on Friday you are getting to know about such a scenario, then definitely you will feel really irritated ki why I have to work on weekends as well. So to overcome this, to avoid this, we can make use of NoOps, that is no operations. So you can see here 2 points I have mentioned. No ops is basically no operations, but that's not the exact thing. We are just trying to eliminate the human intervention as much as possible. And here are some points I have given, like what exactly can be some aspects because of which we need to make use of NoOps. So first one we have is the growing complexity. Okay, so nowadays we can see like whatever multiple organizations are there or different applications we are using. So these are having different services. Okay, so when we are talking about we are dealing with multiple services, then definitely we'll have to make use of like it depends on the like requirement as well. Like if you want to go ahead with one cloud or multiple clouds, or you how many servers you want, how many TPs you want to create, what is the networking thing you want to create. So multiple things are going to be there. So that basically is adding up to the complexity of the entire system. So that is one thing we are having. So if you have a lot of complexity in your system, then definitely making use of NoOps is going to be a really good thing for that. Then we have demand for resilience and agility. So nowadays, like consider companies like Amazon, we are having Hotstar, we are having, and Google, we are having. So multiple companies are there. So these companies are more focusing on how can we be available throughout for the customers. Like even if we are getting too much of load, if we are getting very less load, we want our system to be available throughout so that we can give a very good perform. We can give.
Yeah, you can.
Okay, so that we can give a good performance to the customers. Okay, so that is the main goal they are having. So that is how this demand for resilience and agility is coming in the picture. So that is again no, by making use of this, we can make use of that as well. Then we have business impact for faster time to market. So of course, like suppose if we can take example of this Zomato company. So I guess last year there was a new feature, like one of their customers, he just tweeted something on Twitter, ki, okay, we want this new feature. So immediately they took that into consideration, and within like I guess 2-3 weeks only they created the new feature, and that was deployed as well in the final application. So this is really quick with NoOps. Like if you are planning to go ahead and add some new feature into your application, so that is really gonna be quick. So that is how you can give this faster time to market to your application. And again, we can reduce the mean time to recovery as well. So this is how these all things are gonna contribute to how you can be available throughout to your customers. So then we have evolution of the search infrastructure. So how exactly we have evolved. So earlier how we used to have the manual way, like we had to go to the libraries, the newspapers, the books, so multiple things were there if we are talking about the manual way. Then we are having the search engines. So search engines came into the picture, like Mozilla, we are having Firefox, so multiple these search engines came into the picture. Then again we moved to cloud infrastructure. So based using cloud things, we started to make use of this search infrastructures. Then again nowadays we are having AI as well. So AI is a far advanced version if we are talking about the manual approach and now the AI approach. So this is how the evolution has been. So talking about some key points here. So first I have is monolithic to distributed. So of course we used to have monolithic architectures for multiple companies, multiple things. So how we used to have only one single server which was supposed to handle all the things like the different services and the different databases, whatever different requirements are there, all the load was supposed to be only on one server. So but there were some drawbacks as well. So that is the reason we shifted from monolithic to distributed and the microservices architecture as well. Then we are having earlier days. So earlier days, we had to basically configure all the things manually, like buy the servers, like rent a place. Everything was very static in nature. And when it comes to scalability, when it comes to like identifying the issues quickly, so this was a real trouble back then. Then we are having Elasticsearch and OpenSearch. So as we evolved, like more and more technologies came into the picture, we founded tools like Elasticsearch and OpenSearch as well. So these are basically the open source tools which are going to help us to enhance the search infrastructure. Then we are having new challenges. So of course, even if we are having OpenSearch and Elasticsearch here, so these are also having some cons. So again, so if we are having really large systems with lots of complexities in the same, so that is again going to be a challenge. Okay, so now talking about what exactly is OpenSearch and what is the power point of the same and what is the pain point of the same. So talking about OpenSearch, so it is basically, it's an open source distributed tool which is used for not just the search but also for analytics engine as well. So it is acting as a search engine and analytics engine as well. Okay. And not just the full stack search, but you can go ahead with the log analytics and you can go ahead with your observability use cases as well. So multiple use cases are there which OpenSearch is gonna serve. Then talking about what are the power points of OpenSearch now. So of course it is scalable and distributed in nature. So as I told in the definition itself, so it is scalable in nature and it is distributed. So if it comes to like based on your requirement, you can very easily scale your infrastructure. And then we are having rich search analytics. So of course, like as I told that it is not just going to support the full stack search, but when it comes to log analytics and observability, so multiple things it is supporting. Then operational complexity is going to be there. So like we know that OpenSearch is going to have multiple benefits, like how it is going to ease the job, whatever job we are doing, but it is going to come with a lot of complexity as well. Okay, so you need to hire such a person who is an expert in that particular field, because considering OpenSearch is basically used for multiple scenarios of your infrastructure. If any minor or major mistake you are doing in that, so that is going to collapse the entire infrastructure. So you need to be very smart in that to hire the right person who is an expert in that particular field. So what is the NoOps vision for OpenSearch now? Okay, so NoOps, as I told, that basically we are trying to eliminate the human intervention here. Okay, so how exactly that we are doing when we are talking about OpenSearch now? So of course self-healing clusters. Okay, so suppose if you have created some infrastructure and because of any issue, like suppose your node groups are failing, your pods are like terminated, so any issues can be there. So in those cases you can basically make your cluster smarter, so that they can identify themselves ki, okay, this is one pod, this is one node that is failing, so now I need to basically replace the same pod with some new fresh pod. So that is how self-healing clusters we can create. And we are having automated upgrades as well. So as we are basically eliminating all the human intervention here. So talking about what are the different updates, or if you want to go ahead with some kind of patchwork as well. So these all things will be handled by the system itself. So there won't be any need of any kind of human to intervene and do the work manually. So that all will be eliminated here. Then scalable on demand. So of course, so based on the traffic that you are receiving, okay, so your infrastructure will be scaling like automatically, either scale up or scale down. So that will all happen based on the demand. Okay, so these are the core enablers we are having. So what exactly are some of the tools or tech that we can make use when we are dealing with OpenSearch? So we are having K8s, that is Kubernetes. So Kubernetes is basically going to act as the brain of the system, okay? So that is basically when it comes to scalability or adaptability, or you want to basically like perform this auto-hailing thing. So these all things will be handled by Kubernetes for your infrastructure. Then Terraform we are having, so for creation of the entire infrastructure, whether how many servers, databases, the networking. So for these all things, we can make use of Terraform. And of course, AI we are having. So AI is going to be the one which will be making the entire system very smart in nature. Okay, so that is how we, apart from this also many different tools are there in the market using which we can basically enhance the smart ability of the system. Okay, so I would like to hand over the mic to Rajaram for the next slides.
Okay. So before I talk about self-healing, how many of you have a good experience while booking a Tatkal ticket in IRCTC? You have good experience? Okay. Okay. So whenever whenever I started learning Kubernetes, or when I work on serverless, right, I always feel like I just want to introduce the same thing to for the IRCTC. Like whenever I just want to go and book the ticket, it will say that train is, the logout session, the sessions will be expired or something else. But after 5 minutes, if I go there, the tickets will be completed. I don't know how the same interface is working for other people. I always have this query, and I always feel write some query to the IRCTC. So I have such kind of thing, but it will never happen because it works with the central government. So before I talk about the self-healing, so here always self-healing is something where manual intervention is not required at all. So it's all about, like, if one of the pod goes down, so it has to detect that some pod has been down, and then it has to spin up one more pod, and then that's how the cluster has to work without having any issues. So that's all about auto scaling. And here if I see, so the first thing would be the failure detection. So we want to know, like, if any of the pod is going down, so we should it has to be notified. And then we have automated recovery, and then if one of the pod goes down, and the second one has to spin up instantly, so without having a manual interaction again here. So in case if you are having the one pod goes down, and then SRE is not available, and then someone has to pitch in and then spinning up the new infrastructure, it will take a lot of time. So without having that, our concept is more about no operations, and then where we have to avoid human intervention as less as we can. And then we have a proactive scaling, so that's where auto scaling comes into the picture. And then the resilience, like how the performance and then comes into the picture. So then we are talking about this automated scaling Kubernetes. So here we will be mainly talking about the three things. The first thing would be a horizontal pod auto scaling. So here if they're based on the CPU or memory utilization, so if it is getting more threshold, and then another pod has to be spin up. And the second one would be the cluster autoscaler. So autoscaling is something which has to be in spin up frequently, and then in case if the load is high, and then based on the CPU has to be updated. And then the seamless high availability. So in case the performance has to be equal, and as well as the cluster has to work normal. These are the challenges which we have as of now. So the cluster management complexity, where to design this cluster node and all these things, it will take a good design architecture. Design has to be introduced, implemented, and along with that auto upgrades. So in case there is any upgrades, like some version has to be upgraded, there should be a zero downtime. So that has to be implemented. And then observability gaps. So even if we are using a huge data and then we are having a very limited scope to look into it, it will be the observability, lack of observability will be there. And along with that, there is a cost optimization. So when we are looking at the cost optimization, it has to consider both the performance and as well as the cost. So let's go with a demo. Before one slide.
What slide?
Okay, I'll just take care.
Okay, the steps one.
Yeah.
Okay, go.
So I'll be taking a quick demo. So what we are going to do is here we are creating a EKS cluster and also we are providing IAM permissions role for that, and we'll be attaching the EBS CSA driver installation and along with that OpenSearch deployment. So after that we'll be installing self-healing demonstration. That is the main core object of this session, and we'll be having auto scaling. Also the OpenSearch dashboard access. So let's go ahead and then I'll show you the demo. So here the cluster is already created. So we just need to run this query and then in the Cloud Shell. So once we create this Cloud Shell, so the OpenSearch will be created, and then one second. Okay, so the cluster is already created because it will take a lot of time to do a demo right now. So these are the commands which we run for creating a cluster. So what happens here is, so here the cluster will be created in the default VPC, and as well as the VPC subnets will be created, and also so when we create it, there is a EBS CSA driver policy which has to be attached for that. In case if you are not attaching it, that Kubernetes will not be interacting with the Kubernetes clusters. So that's with the EBS volumes. So that's where we this policy is mandatory to attach to the cluster. So here we are just running this checking the Helm version is installed or not. So once it is installed, so we are just going quickly creating this add-on, that CSS driver as an add-on for the cluster. So that's what the command does, and then we just done that, and then we are creating add-on for that. So then we will be installing curl commands and as well as installing the OpenSearch dashboards. So here if you can see this, so I am just creating one replica with the OpenSearch cluster, and then we are having a CPU and memory of 500 MB and then 1 GB of memory, and the storage I am just giving for 1 GB, and then I am also creating a username and password for the OpenSearch login. So once it is done, so I am just checking the get pods, so to see what all the pods are being running. So that so the OpenSearch cluster master which has been just created, you can see that there is a 7 seconds which has been there, and currently the status is in initializing phase. So I'm just creating the previous one, the load generator, while I was testing it. So I'll just quickly go ahead and then see. So now the OpenSearch cluster is being running. So what next step is, like I'll just going to delete this pod, so that because of the auto scaling, I mean the auto healing has to be implemented over here. So I just done that. So if you can see here, so I'm just deleting the pod. So the pod got deleted. I'm just rechecking whether pod has been deleted. So and also it has been deleted, and if you can see the edge of this seconds, it has been reinstated. I mean it has been recreated. So this is exactly the auto healing came into the picture. And then we're just checking as also we have said automation, right, auto scaling. So in case if any of the CPU or memory utilization goes beyond 50%, so we are giving a called replica set, like if a minimum pod has to be run with 1 pod, and then the maximum pod it has to spin up to 3 pods. So that's what we have set up over there. And then once it is done, then when we are generating a load testing, so once the load testing is done, so it will just create it. So here just we are testing the load testing, and then here we are just adding this cache. So we are running the curl command and to log into the cluster with a username and credentials which we have created earlier. And this is the while statement, so it keeps on curling the command with the credentials and then going to the URL of the OpenSearch cluster. So here if you can see here that here if you can see, these are the minimum pods which are running with 1, and then a maximum pods which you have set up is for 3. So this is all about the auto scaling. So here the things here we'll be noticing more of here is, there are 2 things, I mean there are 3 things. The AAA concept has been implemented, like the auto healing. the first part, like whenever the pod goes down, it has to spin up, I mean restart initially, and then auto scaling. If a CPU or memory utilization goes beyond a threshold 50%, then it has to be spin up one more pod. And the third one is like automation. So that's where we are using the Terraform or the tools, I mean other alternative code that we are spinning up. So so that's all about the topic. So it's all about no ops, in the sense it's all about the operations which makes human without having a manual intervention of a human, which makes the process of the performance of the cluster, which it has to be faster, smarter, and then which a more efficient way. So that's all about our session. So in case if you have any queries, feel free to connect with me or Rajani. So these are our LinkedIn scan QR codes. You can connect with us, and then in case if you have any queries, feel free to reach out to us. And also we'll be having a demo, in detail demo, that we'll be posting it in GitHub, and then the same thing you can get it.
I have uploaded all the deck, like the document and the presentation and everything is there in my GitHub. So if you scan the QR code, just go to my GitHub, and the first repository that I have created, everything you'll find there.
Thank you.
Okay, thank you so much.